Bismillahirrahmanirrahim. This is our third lab, which is basically about image segmentation. The timeline for today's lab is first we will discuss a basic introduction of what actually image segmentation is, and then we will discuss 3 to 4 different types of image segmentation techniques: chessboard segmentation, quadtree segmentation, multi-resolution segmentation, and we will try to apply the contrast split, multi-resolution, spectral difference segmentation, and then we will finally conclude that which segmentation technique is important and what are the advantages of applying different segmentation techniques. So before proceeding on, let's first understand what image segmentation is and why you need to perform image segmentation. So image segmentation, it is basically division or subdivision of an image into objects. Like we have seen in our first lab that when you perform supervised classification or the unsupervised classification on a high resolution data, it gives you spectral mixing, spectral variability problem, different classes they are going to mix. So in order to solve that problem, we will use object-based classification. In order to understand object-based classification, first of all, we need to understand what is segmentation. Segmentation, it is simply division of an image into objects, right, based on similarity and differences. Now, these things will be clear once we will move on. So it is simply defined as partitioning an image into meaningful objects, right? So then we will if we have an image, we divide it into small squares of equal size, for example, and then we name these squares as objects. And later on, we classify each object to a specific class, right? This is simply a definition of image segmentation. Now, proceeding on, we understand this concept that in high resolution images, right, high we have some clear defined boundaries, right? So making objects and classifying the objects, it is more simpler, more easier than you go for the other option, supervised or unsupervised classification. Now we will use eCognition software, and we will see that how we perform this lab in eCognition software. Before we start our lab, let's first go through the basic concepts of today's lab. Okay, I have made this file, and you already understand that object-based classification, it has been evolved as a new technique to classify the high resolution data. As compared to the traditional classifier, this technique is more effective and you can classify the image more accurately. In some cases, you can achieve accuracy of more than 95% classification, right? So image segmentation, it is defined as segmenting an image into meaningful objects. By objects we means homogeneous regions, right? So available approaches, they can be grouped into 3 categories. We can segment an image by using the DN values, we can use edge detection techniques, we can use the region based techniques, right? So eCognition is basically a software that offers you various types of techniques you can apply, various types of algorithm you can apply, and as a result you can get some objects and you can split some objects. If you have a large object, you want to split it into two, you can perform that. And if you have some small object, you can merge two small objects to get a large object. The need of image segmentation, it is very important, basically dealing with the high frequency image of urban areas especially, and where the scene, they have so much complexities. CBDs and the urban districts, they have so much scene complexity and so much there are differences in structures. So to deal with them is to apply object based classification. And in object based classification, we must understand this, that first step is to understand image segmentation in detail. Now this is the methodology that we will follow for today's lab. We will open the image, we will rename the layers, and we will insert some parent and child classes, and we will execute some techniques. Now these 4 important techniques, first one, chessboard, we will see in detail what it is. The second one is Quadtree segmentation algorithm. We will see in detail what Quadtree segmentation is, what are different parameters. Third one is multi-resolution segmentation, and the fourth one is spectral difference segmentation. And then we will compare these four different types of segmentation techniques and see which one is suitable, and then we'll conclude finally some our findings, right? So before proceeding on, let's start eCognition software. Browse to your folder where your software is. I have installed it over here, Trimble, eCognition developer 64-bit. I will start it. Here you have two options. First one is quick map mode, second one is rule set mode. You have to click rule set mode, right, and click OK. Ignore this error and click OK. Now this type of interface is going to open. In eCognition we have discussed you have options of creating workspaces, you can view setting, you can later on we will see once we use this, so that will make some clear understanding of what image object means, what analysis is, what classification options are, how to use them, what process tree is, and what different tools are available, what feature view does. So one by one we will use this tool in the coming labs and get a better understanding. So for today's lab I have shared with you a manual that is performing the image segmentation. The first step is you have to open the eCognition software, which we have done, and the next step is to create a new project option. So you have this option, create a new project, and you have to browse to your study area. For example, lab 4, I have this study area image here. You have to click it and select OK. Now here you have layers. For example, I can rename these layers as double right click, and you can rename this as, for example, if that is blue, okay, this one is green, this one is red, this one is NIR. So we have these four layers we have created. We can select subset option to for image subsetting. If you want to squeeze your area for faster processing, you can select this option. For the time being we will ignore this, whatsoever selection is we will follow that and select OK. Once you select OK, you will have this image over here, right? You can zoom in by scrolling the mouse, zoom out. The first thing, we have to overview our study area, that it contain fields, water bodies, agricultural area, parking lots, buildings, roads, and some shopping plaza type of thing here, some monument type of thing over here, and you can see smaller objects, even cars and other things clearly. So this is a very high resolution image. Now the next step, once you analyze your image, is we have already done this renaming. Now go to the process option, right? And what this process tree is, basically process tree is in eCognition allows you to perform various algorithms, various techniques over here. So you can adjust this window, process tree, right? You can right click and you will see there are different options: append new, insert child, load a rule set, delete a rule set. So once we go on and perform our lab, we will be clear about append new and insert child option. The rule set, it will be clear when we will perform the rule based classification, loading the rules, saving the rules, etc., right? So first we have opened the process tree. Process tree is simply allows you to perform various type of algorithms. Now the next thing what you have to do is right click in the process tree window and open the option append new, and uncheck the automatic option, and we have to type the segmentation and click OK. Now here in our software, this is our process tree. In this process tree we have to use this option of append new, right? So we have to right click and select the append new option. Now here this option, we have to check the automatic and rename it as segmentation. Right now in this segmentation section, we have an option of algorithm, right? So for the time being, uh, we will not select any algorithm, and let's see what option we have here. Now here you can see you have chessboard segmentation, you have Quadtree segmentation, contrast split segmentation, multi-resolution segmentation, spectral difference, multi-threshold, contrast filter. So these are basically different techniques or different algorithms by virtue of which you can divide your whole this image into different sized objects, right? For the time being, let's select this option, execute child process, and we set the options as it is the default and select OK, right? So here we have a segmentation option available. Now the next step what we have to do is we have to insert child. What does this means? This means that in this segmentation what we have created, we are going to execute several algorithms one by one. For that purpose, we have to use this option of insert child, right? So we have to insert some child and then we have to execute different types of segmentations, right? So you can right click and select insert child option. In this insert child, let's select first option. Let's follow this one, chessboard, right? We will first execute chessboard segmentation, right? And let's see what chessboard segmentation does. I rename it as CHESS board, chessboard. Okay, here you can select the algorithm, which is basically chessboard segmentation, object size. Let's use these values as they are and execute and see what this chessboard segmentation does. Execute it. Here is an error, disabling auto naming with an algorithm may cause bugs. You want to execute. Let's select this automatic chessboard one, execute. Now we have executed chessboard segmentation and you will see this type of screen. There is no need to get afraid of, just adjust your window and let's zoom. Now here you can see that the whole image is divided into equal size square, right? And these squares are very small in size, so these squares are basically your object. Now if you select this edit option, right, you have this parameter over here, object size, right? So you can change the object size from 1, let's we change it to 10 and then execute it. Now as we have changed our object size, the size of the square has sufficiently increased. Now this concept is very important. When we have a small size square, it will have similar class or homogeneity. As we are increasing the size of the square, different classes they are included, which means the heterogeneity is included. Let's edit it again and select it to 50 and execute. Now more bigger size square they are formed on whole image, right? So this is the chessboard segmentation. You can zoom in and zoom out. Now this segmentation technique, it is very important, but it has some advantages and some disadvantages. The major disadvantage is it divides the image into equal size square. For example, in our case, what we have when we have performed, so all the squares they were of the same size. A roof, it may and a road, they may be incorporated or they may be included in a single square. For example, if I just zoom in, select the pen tool and zoom into this option. Now in this square you can see that a building roof and a shadow, both of them, they are included in the same square, in the same object. So this classification has a major drawback that it does not take in the spectral response, or this does not take the does not divide the object accurately, right? It does not divide the picture on the similarity base. So various objects, they are going to mix, like we have seen practically, and we have seen over here. Now the major disadvantage of this technique, we have discussed that objects, they are mixed and they cannot be differentiated. So what other option do we have? Now going towards the next option, that is Quadtree segmentation. Okay, I think we are now clear with chessboard segmentation and its disadvantage. Now the next algorithm is Quadtree segmentation. Let's see what Quadtree segmentation is. We have to insert child and rename this as quad. Okay, you have to rename it over here, quad tree segmentation. You have to select the algorithm, which is quad tree based segmentation. Now in quad tree based segmentation, we have the option of scale. What does the scale means? Like in the first chessboard segmentation, when we increase the scale, so when we are going to change the scale value to a larger number, the size of our square, the size of our object, that will increase. Now by increasing the size of this square, we are allowing the heterogeneity, that different classes, they are going to mix. Let's execute by a first smaller scale, that is, let's say 10. And quad tree segmentation, it is based on, you can select different option, pixel level, object level, and other. For the time being, let's select the pixel level and select the execute. Okay, let's check this automatic and click the execute option. Now quad tree segmentation is being executed. We will see what advantages or what disadvantage this technique has. Okay, by setting a smaller scale value, we have objects, they are formed. And let's analyze some object. Let's analyze buildings. Okay, so the size of the object, that is very small. You can see that a single road, it is being divided into very small objects. Let's edit it so that things, they are visually clear. Let's set it to 60 value and execute it. Now on the size, we have selected 10. Our objects, they were smaller in size. Now we are going to we have selected the size of 60. Now the large size objects, they are formed. But one important thing is to note that these objects are not of equal size. Now these objects, they are divided into various shapes, various sizes, based on spectral property or the pixel value which we have selected, right? Now in this edit option, let's change the scale value from 60 to 120 and execute it. So what we are going to expect is that the size of our object is increasing more, right? So at the 120 scale, we have a slight change in objects. Okay, this roof earlier at the scale of 60. Okay, now good thing is that in the 120 scale value, this roof is being divided into 1, 2, 3, 4 and smaller some objects. Okay, we have executed quadtree segmentation. Now quadtree segmentation, it divided the whole image into different size square it was not like chessboard segmentation, which divides image into equal size square. The quad-tree segmentation was different. It divides the image into different size square objects. Quad-tree segments the image on the basis of similarity of spectral response. Spectral by mean what is the meaning of this statement? On the basis of spectral response, that where the dn values they were similar, one object is formed, where dn values they are being changed, different objects are formed. The region in the image where spectral responses were similar, so large segments will be formed, and in the region where they are dissimilar, smaller segments they will be formed. We have observed that, for example, this is a similar region. Here one object is formed. Now this region, it is different from this region, so there are different objects they are formed, and in some cases we may have uh, mixture as well, but this mixture is very that is lighter, that a very slight changes being observed over here. So we have executed two segmentation techniques. uh, we have executed the chessboard segmentation technique, and we have executed the quad-tree segmentation technique, and we have seen the disadvantages that are associated with both the techniques. Now, the quad-tree segmentation, although it is a very good thing, but it does not divide or classify, provide a base for classification so much more accurately. So let's move on to something more better, right? Now, after performing the quad-tree, let's execute now the multi-resolution segmentation. What multi-resolution segmentation is basically that it uses the pixel values, right? But not the just the threshold view, which we will be setting, but it is repetitive process until it improves to a sufficient level. It keeps on improving itself. So multi-resolution segmentation algorithm, it converges or it consecutively merges the pixels, right, or the objects. So by iterative, it means it is an iterative process which repeatedly occurs, right? Now, in the previous segmentation technique, that was quad-tree segmentation, we have only one parameter to change, that was scale. Now we have shape as well as compactness. Now let's execute it and change these values and observe what we get, right? So here we are going to insert child, and we have to insert child with the, now our algorithm will be multi-resolution segmentation. Now you can see we have a scale parameter. Let's set it to 70. Now on the scale parameter of 70, and let's select the shape. For the first, I am selecting it to be 0.8, and compactness I am selecting it to be 0.2. These are two very important concepts, the shape, compactness, and the scale we have already discussed. Now let's execute by 0.8 and 0.2 and see what we are going to get by this type of segmentation, right? Let's rename it to multi-resolution segmentation. Let's check it automatic. Okay, execute. Now multi-resolution segmentation is being executed. It will take 1 minute and 30 seconds approximately. Now let's discuss for the what does the shape means and what does the compactness means, right? When you are going to assign shape a higher value, so if you have a roof, it will give more weightage to the shape of the roof. If you are selecting the 0.8 value, it means you are assigning 80% weightage to class make your object, right, basis on the shape of that object. For example, you have a rooftop, so more weightage will be given to the shape of that roof, right? So if you are assigning compactness great value, it will not go for the shape parameter, but it will go for the spectral parameter, that is the pixel values or dn values, right? We can specify different values to shape and compactness. So if you are interested in getting the build, so if you are interested in getting the buildings, right, or the building tops, so what is preferable for you is to assign more weight to shape. But if you are studying a phenomena that has more spectral variation and objects they are spectrally dissimilar, so you can assign instead of the shape compactness more weightage. So once this algorithm is executed, we will analyze it and see that what advantages or disadvantage this parameter includes, and how we can compare it with Quadtree or the chessboard segmentation, right? So it is approximately done over here. It's completed, right? Yes. Okay. Okay, let's analyze what we have run by setting the shape of facts value of zero point 0.8 and compactness a value of 0.2. So we can see that our image has been divided into various small and large objects, and in this case more weightage is given to the shape, right? So if we zoom and see that rooftops they are delineated, right? So this is the impact of giving the shape more factor weightage. If you select this one, okay, so this is they are separated. In some cases there may be some mixing as well, which might like this, a small patch is mixed with this roof. So this is basically setting shape zero point 0.8 and compactness 0.2. Now let's change this value to 0.5 and 0.5. We are setting the shape and compactness 0.5, so it will capture the uh, shape information, and as well as the it will capture the compactness as well. Now a question arises that what compactness is. It is only about how can we define compactness, right? So I have opened this lecture over here. Compactness, right? Compactness, it is basically the ratio of pixel border length and the square root of number of pixel which form the object. It is similar to the word compactness we use in normal English, that how compact your object is, that how much length your border pixel, the object you have formed, how much length it has, and how much number of pixels that is forming. Similar, like we have a density formula, that is mass per unit volume. So this formula of compactness is the length and the number of pixels that they are forming, right? So this is about the compactness, right? So once we have executed this by setting this value of zero point 0.5 and zero point 0.5, so we can move on. We will wait for 30 seconds and then we will start again. Okay, we have now executed the shape with zero point 0.5 and compactness with zero point 0.5, and as a result we have this type of image. Now you can see that your shape has been given less weightage. In some cases your roof is being divided into two, but it has made some objects which are now more compact, right? So most of the roof they are being splitted into one or two, and compactness is now included. So this is all about running the multi-resolution segmentation. We finally conclude that this is an iterative process which give user the control of scale, which give user the control of setting the shape parameter, and setting the third one was compactness parameter. So three things are under your control, but still we can improve the multi-resolution segmentation by setting these parameters based on the imagery. Now important thing is to move on and improve our results more, right? So for that purpose we have another segmentation technique, which is spectral difference segmentation technique, right? In this technique a user can select a threshold value, and this threshold value will be used to merge the objects which have a spectral difference below this threshold. So it is defined as a merging algorithm where neighboring objects with a spectral mean below the threshold will be merged to produce the final objects. So in order to use this algorithm technique, we must have already a segmentation level in place, that we cannot create a new level using this algorithm, right? So this algorithm would accurately classify your accurately segment your objects, accurately segment vegetation, roads, houses, and even shadows. They will be segmented. Let's execute it and understand what this segmentation does. We have to insert the child and we have to execute our algorithm, that is resolution. We have already done spectral difference segmentation, right? So we have to assign the weight. Let's assign 15 for the time being. You can change the image layer weights, you can change the threshold condition, and let's execute it, right? So now once it is being executed, we will see that how effective this technique is. So it has been executed, and this technique, spectral difference segmentation, and that was it is executed very faster as compared to the previous techniques, and let's see it's how effective it is. Okay, now if you click on this road, you can see that all the road is segmented into one object. You click on any building roof, it is segmented into one object. You click on any other body, that is properly segmented. So this is the advantage of spectral difference segmentation, that it very accurately defines or segments your object. So right, so we finally conclude that this algorithm is where the neighboring objects with the spectral mean below the threshold given will be merged to produce the final objects. Using this algorithm, we accurately segmented various classes like roads, like buildings, and if you can zoom in and see the shadows as well, so you can see that shadows are also segmented very clearly. So this segmentation technique was most effective technique as compared to the previous techniques. So let's have a revision of what we have done. We have executed chessboard. The major disadvantages: it divides whole image into equal size square. We have executed Quadtree segmentation. It divides the image into different size square objects. We executed multi-resolution segmentation, which is an iterative process, give you the control over scale, gives you the control over shape and compactness. We executed the spectral difference segmentation. That was the most effective technique till now. Now this segmentation has clearly segmented shadows, clearly segmented the roads, and clearly segmented other objects. So for the time being, we conclude that this spectral difference segmentation was much better than the three segmentation techniques. Thank you. That's all for today's lab. Now in the next lab, we will proceed on.